In this video, I'm going to demonstrate how to perform a Games-Howell multiple comparison procedure on data measured on an ordinal scale. Now, the example that's provided is based on data that are from the vegetables and children study in terms of trying to motivate them to eat vegetables and whether they would like them more under 4 different group conditions. Dependent variable is measured on a scale that is 3-point. And so most people would argue that you can't perform a parametric statistic on these data. And in a previous video, I tested the hypothesis of equality across the groups in terms of mean ranks with the Kruskal-Wallis. And I also did a one-way between subjects ANOVA on rank data. But the problem of homogeneity of variance was there because the Levine's test was statistically significant. That was both from the procedure based on medians as well as the procedure based on the rank data. So I proposed in the textbook that one way to get around this problem, and it's an attractive solution for a number of reasons, is to perform a Games-Howell multiple comparison procedure because it doesn't assume a homogeneity of variance, it does not assume equal sample sizes. And when you use bootstrapping, it doesn't assume that the dependent variable is measured on any particular scale. So to conduct the analysis, you could do so under 2 pretenses. You could convert these data into ranks first, but I think I would prefer to just stick with fully informed dependent variable. So I'm going to leave the data like that because bootstrapping doesn't assume that the data measured on any particular scale. So click on Analyze, Compare Means, One-Way ANOVA, and put the rated liking variable in the dependent list and group into the factor list, and click on Bootstrap, and click on Perform Bootstrap 1000 replications, and Bias Corrected Accelerated. Click Continue, Post Hoc, and Games-Howell, and click OK. And you just have to wait. You can see that the analysis is being run a number of times, which is the resampling procedure, and that can take a few seconds depending on the sample size and the number of groups. And so here we have bootstrapped multiple comparisons at the end of the output, and we can rely on the upper and lower bound associated with each comparison. And so in each instance where the mean difference, which is negative here, so long as the lower and upper bound are also negative in direction, these are the 95% confidence intervals, so long as they're in the same direction as the mean difference, you can conclude that there is a statistically significant difference between those 2 groups. So control and exposure have a mean difference of negative 0.59. That's based on the 3-point Likert scale. And I can trust that there is a statistically significant difference there, because I've used bootstrapping and I've used the Games-Howell procedure. We can also see that a number of comparisons are not statistically significant. So for example, the difference between exposure only and exposure and tangible rewards was not statistically significant because the point estimate is negative at negative 0.145, but the lower and upper bounds are not on the same side. So the null hypothesis has not been rejected in that case. Now, interestingly, the exposure group plus exposure plus praise is actually statistically significant, just barely so, because the lower and upper bounds are both negative, just as the point estimate is. So it actually, based on bootstrapping Games-Howell, there is a suggestion that the difference between exposure only and exposure praise is actually statistically significant. But that is not the case when you use the absence of bootstrapping, which is asymptotic normal distribution theory. In this case here, it is not statistically significant, and it's also not statistically significant if you were to do a series of Mann-Whitney-U multiple comparison procedures. So that's interesting that the bootstrapping procedure is suggesting a statistically significant effect, and so I would probably trust these results over any other comparisons in this context, and it'd be great when people start doing simulation research to show these types of results as robust across a number of conditions.